Talk about the sum to infinity, this will only ever be with a geometric series, okay, because all arithmetic series diverge. So what you've got here, because the geometric series, we need to always remember our background knowledge, which is that that's basically an exponential graph, okay? So you can have ones that start at a particular asymptote and go infinitely upwards. So these guys diverge. You can have ones that have the asymptote wherever, and then they go up towards the asymptote. So these little numbers get smaller and smaller apart from each other, okay? And those ones converge, and it's only with the ones that converge that can actually go to infinity. You could sum to infinity here because infinity is going to be that asymptote if you add up everything. Okay, so you've got to have a converging one, and the way that you're going to understand that is you're going to be looking at your R. Okay, so if R is a big number like 2, 3, 4, whatever, then the whole thing is getting absolutely massive as you go along and it's diverging. But if R is a fraction, which means it's somewhere between -1 and 1. Can it be 1? No, because if it's 1, then you don't have a geometric series or sequence, okay? Because then you're just multiplying by 1 every time and you're just getting one of those patterns that goes 7, 7, 7, 7, okay? So it can't be 1, can't be -1. It's got to be a fraction in between there. It's got to be a proper fraction, okay? And that's one way in which you can test whether something can have a sum to infinity. So sometimes they say if it exists, which is normally secret math teacher code for it does, and you better calculate it. But sometimes they ask you whether it exists, and then you'll get like there'll be p's and q's maybe in the constant ratio, and then you'll solve for that, and you'll put your quantity like 2p minus 1 or something in between these two, the -1, and then you'll solve for the inequality, and you'll be able to say yes, well, it would exist if p was whatever number you get out as your answer. Okay, so sum to infinity is going to have to be, that will only happen, you'll only get a sum to infinity if you have those conditions. The formula for that is going to be your sum to infinity equals a over 1 minus r, even easier than the other ones we've had to learn so far. R can never be 1, so just make sure, look, this doesn't come up often, but it's just really good to remember, and when you're writing down a formula, to put that down as a restriction to yourself, to remind yourself that should that occur, you've obviously gone completely in the wrong direction. A really basic example, let's say we've got a series 1 plus a half plus a quarter. You can see it's getting smaller and smaller, okay? Dot, 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 and they say calculate the sum of that to infinity, okay? So your sum to infinity is going to be this formula here. You need a, you need r, it's just two variables, okay? So a is clearly 1, so my sum to infinity of that would be my a, which is 1, over 1 minus r. So a half divided by 1 gives me a half. So I've actually just worked all of that out in my head. That's 1 over a half. So the sum to infinity is 2.